Okay, in this video we are going to look at code for a linked list. First of all, just remind ourselves the basic idea of a linked list. Alright, basic idea of a linked list is we have some boxes that contain some data. In this picture there's a word, a length, and a count, and then there's next and previous pointers. So the linked list is made out of these boxes. We call them nodes. And then when you want to put something new in, you want to put it in here and adjust the pointers so that we still have access to everything. So we would have these pointers and a previous pointer there as well. We always keep the head pointer. That's sort of where everything starts. And then if we want to look for something inside of the list, we basically have to look through each box. So this is very similar to an unordered array, but we don't have to allocate space ahead of time. Every time we're going to add something new, we create a new one of these nodes and then put it in. We have a list.h file. So our node for the example we're going to do is we have our word data. So the word T is this type here that has a spot for a string, how long is the string, and what is the count for this is doing word frequencies. So this is going to be our node. We have the data, we have a previous pointer and a next pointer, so that just matches up with this picture here. So then the main things that we're going to do is a lookup, insert, and print. Let's do the lookup first. So here's the lookup. We have the head pointer, so there's some head pointer, and then we're looking for some word. And we basically just want to loop through and look at this one, and then this one, and then this one, and then this one, and then this one, and eventually we get to a point where the next pointer is null. So this is a loop to just memorize. I'm going to put it in here, and then we can look at the picture again. Okay, so here we have P, which is a pointer to a list node. Initially, we're going to set P to be equal to the head, so we could have a P item here, and that is pointing to one of the nodes. Initially, it's sitting on this one. Let's say that we're looking for the word of, let's say we're looking for the word because. We're looking for because, we set P equal to the head. We check to see, is it equal to the word here? No. So in our for loop, there's the head. It's not null. We compare it. If we don't get 0, that means we didn't find it. Then we go up and do the increment. For the increment here, we set P to be next. So P is going to go to the next pointer. So that would move P along here. And then we would do the comparison. Is P null? It's not. So we go inside the loop. We do the string compare. If we're looking for the word because, we would see it's not equal to because here. And so then we would go up and do the increment, which puts P to be next. And we keep going like that as long as P is not null. We keep setting P to be P next, P next, P next. Eventually, if we're looking for something that's not there, P P will be the next pointer of the last item, which will be null. So if we ever find the word, we return a pointer to that node. If we get through the for loop without returning, that's null. Okay, so what you want to do right now is maybe take a pause. Here's your picture, and then say to yourself, what is the basic idea, what is the basic algorithm for doing a lookup in a linked list? All right, now another basic question is the running time of this. If you have n items in the list already, so the running time, it is order n. It could be very fast if you find the item quickly, or if the item is not present, you have to look through the entire list. So the next thing I want to do is the next easiest, which is printing the list. So printing the list, we're going to again have this where we want to go through the entire list. Now we're not looking for a particular item, we just want to print each item. So P is head. While P is not equal to null, P goes to P next. And then in here we just want to print P. And we had a function for that in the words.h. Print word. So we print word with P and F. Let's see, P data. P is a list node. The data member is a word underscore T. And a word underscore T we have a print function for. So that is print list. Then the other thing to do is an insert. When we do an insert, we create a new node, and then we want to update pointers. So the creating the new node here is the same as, very much the same as when we did a binary search tree. First we need to create the data. So the data is a word T. There's a make word function that just creates the space for the word T, initialize pointers to null, and then copy the word in. And if you want to see those functions, that's in words.c. We had mk word and init word. So you can pause the screen for a second if you want to review those. This gets the data all set up, and then it would be time we need to make our node box. So that's going to be a list node underscore T make node, which I haven't, let's see, which we have something up there we can see what we think of it, and then putting the data in. So let's check out the make node. So we just want to do a malloc for the data structure for the node itself. So the size of the node itself is a list node underscore T. And what would be the size? We need a pointer to the data, and we need 2 pointers to list nodes. So that's the size of 3 pointers that are in our structure. So that mallocs it, we typecast it to be a node pointer, and we save it into a pointer variable. Initializing things, the data initially is empty, and then pointers are initially null. We have the data being null and the pointers being null, and then return a pointer to the new node that we created. That is this line here. So PP will be a box that we've initialized to have null values. And then we have our data, which we just initialized here. So we have our new box with data pointing to the data we just created. Okay, so now there are a couple cases. If it's the first thing that we're inserting, then the head will actually be a null pointer. And what should we do in that case? So the thing we should do is, if it's a null pointer, we're just going to point the head to be our new node. So if star head equals null, then we have star head equals pp. Star head is of type list node t. It is a pointer, so we're passing in a double pointer here because we might modify head. So we actually have a pointer to the pointer head, and we might modify head. So there is that case. All right, otherwise, put the new node as head, and if we're here, head is already pointing to something. All right, so if we're here, then we did not do the head is null. So what we want to do is we need to set the previous and next for the new node, and the next should be just whatever head is. So next is star head, and then we need to update the previous pointer for whatever's there to be the new node. So we can want to put these two arrows. So we have star head previous is our new node. So those would be two arrows going right here. And once we have those arrows going, then we just update the head pointer to be pointing over to our new node. That should be it. Okay. So that's the code for insert. We create the data, we create a node, we have those initialized, and then we just need to update pointers to put the new node into the list. All right. Now we want to put this into our words program. And we're going to have list node t star head equals null. And then inside the list here, this was our loop where we get a word, we want to do a lookup. So we're doing a lookup with the list, and we either get null or not. If we don't get null, then we increase the count on the data. If we do get null, then we want to insert it into the list. When we're done, we print the list. All right, so the code here doesn't really change depending on the data structure. We just put in our lookup for the data structure we're using, and we put in the insert for the data structure we're using, and the print. Let's see if this compiles. It does. Now let's see if, let's call this, instead of SB, it's L. SL, and we'll give it some file. Why don't we give it the make file? There are some counts, and they're in the order that they appeared, reverse order that they appeared. The compiler is the first word, GCC is the second. That looks okay. All right. So what you want to do is you take a pause, describe to yourself what basically happens in each of these functions. Take a pause. and then you can check the code that we just created. Alright, that'll be it for this, and then we'll look at a homework assignment using the list as our next video.